All right, hello students. This video is hopefully a short video just explaining the rocket activity. So you're going to build rockets of some type. I'm going to provide directions on how to do it with a film canister and Alka-Seltzer and water. You can use a film canister and Coca-Cola and a Mentos. And there's like stomp rockets that you can Google how to make. There's ones you can purchase. There's lots of different options for you. For building rockets. If you're unable to get the supplies, you need to contact me so I can arrange to somehow have you pick up the supplies from the school. I'm hoping most of you can find the supplies at home or find something you can do at home. You just need to make sure that you can measure the max height that the rocket goes and the distance that the rocket lands from its launch site. So you have to be able to measure two things. So you don't want to buy one of those like really expensive rockets going to launch down your street because you can't measure the max height. You can't even estimate it very accurately. So just keep that in mind and let me know if you have any questions. So what I'm going to do now is I'm just going to kind of go over that additional document that was provided for you. So the purpose of this activity is to determine the equation for the parabolic motion of the rocket. That's the purpose of this. We're going to figure out what the equation is for your specific rocket. All the rockets are going to be different. I should not have two students submit the same equation for different rockets because they will not have the same ones. The hypothesis, the formula to model the flight of a rocket will be, what kind of shape do you think it's going to make? It's going to be a parabolic equation. You don't have to estimate in your hypothesis what the numbers in the A, P, and Q position are going to be, but that's something that you should be able to say what kind of shape or kind of equation it's going to be. All right, so here are some, in these directions, sorry, I also wanted to mention that there is what the materials you need, and this is for the Alka-Seltzer film canister ones. There's some definitions, there's some explanations, there's some tips. And here's the launch procedure. Okay, so it does actually go through this, even though I have done a video of me launching the rockets. It kind of goes through it in a more succinct way with steps. Okay, so what I wanted to cover today, though, is just what it's going to actually look like. So you're going to have certain values. So I had, I think it was 87 was my maximum height, and the distance from the launch pad. So my rocket went up and down like this. So the max height was 87, and I measured it against my garage door because it was kind of easy to spot how high up it went. Is this an exact measurement? No. It was an estimation of how high it went up. You're also going to measure the distance from the launch site that it lands. So that was, in the first case, I think it was 77 centimeters. So you're going to repeat that multiple times. So you can actually cut an Alka-Seltzer tab into halves and you'll get a really good explosive result. And it also gives you a little bit more time to get the cap on and set it down on the ground without it exploding into your hands or into your face. But you can also cut it into quarters. You just have to be a little bit more patient and realize it's not going to go as high. So it's a lot more exciting if you use half a tablet of Alka-Seltzer. Don't use a full one. It's kind of wasteful. So let's say that I finished that activity and I did the trial. You should do the trial at least 3 times at the very minimum. So let's say I got a couple more results. Usually it's going to go down a little bit as you go because it starts to get a little waterlogged, because no matter how hard you try not to, water is going to get on your rocket. And let's just say that no, you're not going to fabricate your results. Okay, so what you're going to do, this is me doing 6 trials. I've given you additional spaces here in case you do additional trials. It's kind of fun to blow up rockets, and it gives you an excuse to go out of the house and do something. After we shot the videos, my son and I blew up my rockets because why not? So you can do this as many times as you want, but you want at least 3 trials. right? So then you're going to average these numbers. So you're going to count up 87 plus 87 plus 86 plus 85 plus 84 plus 83. I'm not going to pull up the calculator on the same screen, so I'm just going to do that on my phone. 87 plus 87 plus 86 plus 85 plus 84. And then I have 6 trials, so I'm going to divide that number by 6. So you're finding the average. And in this case, my average is that it was 70. Ooh, I don't know why it does that sometimes. It's so annoying. 71.5 does not look right. I'm going to redo that. All right, so 87 plus 87 plus 86 plus 85 plus 84 plus 83 equals divided by 6 trials. That's better. It's 85.3 is my average. I don't know why it does that sometimes. That's so annoying. 85.3. So you're going to want to average your, so that's the max height had an average height. Okay. You're going to do the same thing for your average distance to launch. Okay. So I'm going to do 77 plus 77 plus 76 plus 76 plus 76 plus 80. And again, because I have 6 launches, I'm going to divide it by 6. If you only had 3, you would divide it by 3. And this gives me the average distance as 77 centimeters. So that's the average distance. Okay, so if you were to put this on a plot, you start at your origin is your launch site. Okay. The coordinates for your launch site happen at 0, 0. Okay. You know you went up to a max height of 85.3. So this happens at, you don't know the x coordinate yet. I'm going to tell you how, I'm going to give you a hint on how to get that. But you do know that the height at which it occurs, the max height, is 85.3. So the coordinate of this max height, which is a vertex, is at something 85.3. And then it lands here. The height is 0. So you know the y coordinate of that point is 0, and you know the distance, the max distance it went was 77. So you have already 2 points of this parabola, and you can get that third point really easily because the vertex coincides with the axis of symmetry. And we know that 2 points on an axis of symmetry, like this point and this point on a parabola, so not on the axis of symmetry, are equidistant to that axis of symmetry. If that whole distance between 0, 0 and 77, 0 is 77, where would be halfway? So you would take your 77 and you'll have a different number. You should not have the same numbers as me. Is going to be 38.5 because you split that distance in half because they have to be equidistant. So that means this vertex happens at 38.5. Okay. So now you can construct an equation in vertex form, all right? Because you have the vertex right here, right? So you have your P and Q value, and you have another coordinate that you can use to substitute in for X and Y to solve for A, okay? Once you have your vertex form, oh, here is the graph part. Oops, I forgot I actually gave a graph part. You can graph it here, and then you can do the analysis questions. All right. Let me know. I'm not going to go through and give you all the answers for that. I want you to show me evidence of your understanding of these concepts and construct those equations, the parabolic motion of your rocket in Vertex form. All right. Let me know if you have any questions. Hope you guys are doing well. Take care. Bye-bye.